YouTube viewers. In this particular video, I'm going to go over how I installed my weather station and set it to report both to Weather Underground and also to the Citizen Weather Observer program. I will show you a video of what the weather station looks like, and I will also show you a video of how I have it set up upstairs with the Raspberry Pi connected to the weather station base. Additionally, in this video, I'm going to show you my amateur radio antenna setup in my backyard. So sit back, relax, and I hope you enjoy. This is the Accurite 5-in-1 weather station that I ordered from Amazon. The alignment is important because it must face south for the solar panel to be able to do its agitation to help record the amount of rainfall more accurately. The station is mounted about 5 feet off the ground. It uses 2.4 gigahertz to send the weather readings into the base station inside the house. Here you can see the Raspberry Pi on the left connected via USB to the weather base station that's on the right. The additional cable needed for the Raspberry Pi is to power it. Here you can see the base station. The backlight isn't currently on, but you can see the wind speed, direction, temperature, humidity, and various other pieces of data. When connected to the latest Raspbian distribution of the Raspberry Pi, the USB connection to the weather station base automatically enumerated. No driver downloads or kernel modifications were necessary. Next, we'll go into how to configure the Raspberry Pi to receive the data and send it to the various sites. Alright, so I've logged into my Raspberry Pi using VNC. I like to enable VNC in Raspi-config as one of the interfaces. It makes it easy to log in remotely since I do not have a monitor connected to this particular Raspberry Pi. It's actually mounted on the wall, as you could see from one of the pictures. So to install the weewx software that I use to grab the weather from the Accurite weather base and then publish it on the web to Weather Underground and CWOP, I went ahead and installed that software. It's not part of the default Raspbian distribution. However, what I did, and I will pull this up, using my history to show you basically what I did to go about installing it. The first thing I did was I went ahead and, well, I attempted to install it, but it wasn't actually part of the Raspbian distribution. So I did a search on it and found it wasn't there. And then I looked online and found that if you can download the key for it and then use this command to go ahead and grab the source list, then you can go ahead and use apt-get install to install it. And then during the install, it asks several questions: latitude, longitude, how high it's mounted, give it a name, also what type of a weather station is it. And then it pre-populates the config file, and I'll go ahead and edit that. It doesn't ask you about what services to publish to. I don't believe, anyway. I think I had to edit these settings myself. Besides, you have to set up a password, use a passkey to publish to Weather Underground. The same for CWOP. So I'll go ahead and look at that file. And most of the settings in here I did not change. I may have turned the log settings up so that I can debug, but it's working now. I could probably set those to false. The next few sections are basically what you entered when you installed it with apt-get. Latitude, longitude, location. Note that the latitude and longitude are in decimal degrees and not in degrees, minutes, seconds. From Google Maps, when you're finding your location, I believe it defaults to decimal degrees. However, I think there's also a setting you can change it from one to the other. The other thing is to set the altitude. I chose to set mine in meters, and you'll notice that the unit here is actually singular. You'd want it to be meters, but it's actually meter. I believe if you put it in feet, you would have to specify the value and say foot. I believe it wants the singular. The next few sections are basically for what services you want to publish. So I'll go down there. And CWOP is one section. You can put in a station ID if you have a CWOP station ID, and I believe that's it's Citizen Weather Observation Program. I'm not sure 100% what it stands for, but since I have an amateur radio call sign, I go ahead and put my call sign and an SSID in here. I actually have another weather station somewhere else that's set to just my call sign. So to differentiate, I put an SSID of 11 on the end of this. However, if you don't have an amateur radio call sign, you can sign up through CWOP and get a station identifier. The next section is for Weather Underground. Actually, I don't use these two services, but Weather Underground is the next one. And essentially what you put in here is set enable to true. Put your station ID that you got from signing up on Weather Underground for a personal weather station, and then put in the password that Weather Underground told you to use for you to publish your weather. The rest of it is filled in automatically. They're the defaults. And we can go ahead and look at how the published weather looks. Here's my weather station here. Current wind and temperature. You can also see a few other values down here in additional conditions. I believe if I click on this, yeah, it gives a little bit more specifics on this particular weather station. Dew point, humidity, rainfall accumulation, shows your station on a map, and it gives you some nice meters. The other thing that weewx has by default is its own website that it publishes. So if I go to you can see you can get monthly or yearly reports or look at conditions over the course of a day or a week or a month. However, I only have a partial month because I just installed this apparently late in the evening on the 20th, because that's when my data starts. But they have a nice published website here that you can look at to get additional information. So essentially my station is configured with a Raspberry Pi connected to the base, and then I publish that weather to CWOP, Weather Underground, and then I can look at the local website if I want to see additional information, as the weewx website that it publishes actually has some nicer graphs. So sometimes I look at this over the Weather Underground pictures. What's pictured here is my 20-foot tower. On top of it is a 10-foot steel mast, and then on top of that is my UHF VHF 2-meter 440 dual band base antenna, which is currently connected to two things through a duplexer. The first is my APRS packet station, and the second is my hotspot, my MMDVM hotspot that I use for DMR and Yaesu system fusion. Although the hotspot only puts out about 20 milliwatts, I can still get about a mile away from the station and utilize my HT to use the hotspot to get on either system fusion or DMR. Pictured here is a zoomed in shot of the top of the tower. What you can see near the bottom of the top of the tower is a black box. That's my MFJ 300 watt antenna tuner. Coming off to the left side of that is an end-fed wire which goes to a tree across the yard, and I use that as a NVIS antenna, near vertical incident skywave, for local communications on the low bands. Up a little bit higher, you can see the mast, which is a silver metallic 10-foot mast, and on top of that is the dual band VHF UHF antenna, and that particular antenna is around 6 feet tall. It's difficult to tell with the angle and the zoom of the picture, but it is a fairly good gain antenna on VHF and UHF. Transitioning inside the garage, here you can see a somewhat messy setup. You'll see a PC power supply where I have a couple of the motherboard pins shorted out, which keeps it powered on. Additionally, I'm using a PCI Express plus 12 volt supply to power both the HT. There is a Yaesu HT. Underneath it is a 2 meter only 25 watt amplifier that also includes a preamp. That's a Radio Shack model. And then you can see the duplexer, the MFJ duplexer off to the right. On the 2 meter input side is, of course, this APRS setup. The radio connects into that, the Yaesu 2 meter HT. On the right side is my MMDVM hotspot. Here's a zoomed in picture of the actual Yaesu rig. This HT puts out about 5 watts, and then the amplifier underneath it amplifies it to 25 watts. I also like the preamplifier, which seems to work fairly well for APRS digital mode. Between the amplifier brick and the radio, you can actually see the Argent Data Systems APRS tracker that I'm using. Here's another photo of the Radio Shack 2 meter power amp. This is something I picked up back in around 1994, and it's been in a box since 1994, so it is, oh gosh, over 25 years old, but it was well made, and it's still putting out 25 watts of power. On top of that is the Argent Data Systems Tracker 3 APRS TNC. You'll notice it has several digital and analog inputs that can be used. I'm not using it for any of the digital or analog inputs. It's basically just sending a signal from the Zaster software, and then it's modulated and sent through the Yaesu HT and out the amplifier for the APRS signal. The Zaster software is used on a Raspberry Pi. Now here is the close-up of the MFJ duplexer, and like I said, APRS is on the left side for the VHF portion, and then I have my MMDVM hotspot on the right side. That is just a double male PL259 that connects the duplexer and then also through an SMA adapter directly into the hotspot, so there's no cable involved there. It's just directly connected to the duplexer. Now the setup, like I said, for APRS, for it to be an iGate, is I have a Raspberry Pi in amongst that mess of wires, and it is connected via USB to that tracker, and I essentially gate RF to the APRS IS, and I also gate APRS IS to RF as well. Transitioning back outside, here you can see my 43-foot vertical antenna. At the base is an ICOM AH4 remote antenna tuner, and it is connected to a wire that's inside that telescoping fiberglass pole. The fiberglass pole extends to 43 feet with the antenna element wire inside. There's a ground system underneath with think I've got around 10 radials coming off of it, various lengths, just to the extents of the yard. Also, I put a plastic coated section of chicken wire on the ground as well to act as additional grounding to give that vertical something to push against to get its RF out. I really like the vertical antenna. It's given me a lot of DX. I was able to get DXCC using digital mode FT8 just recently. The final piece of the setup is actually the other end of the end-fed wire. This is a tree in the back corner of my backyard. There's two 10-foot sections of 1.5-inch PVC that are joined in the middle. It extends upward, well, it'd be 20 feet, and the other end of the end-fed wire is connected there. The end-fed wire is somewhere around 60 feet, and it is not very high off the ground as far as being a quarter to a half a wavelength like you would want for low bands like 40 or 80 meters. That would be awfully high up. I don't have a big enough tree to get up that high. However, I'm using this for my Mars setup as a NVIS antenna near vertical incident skywave. So a lot of the radiation is upward because it's so close to the ground, which is just fine because provided the maximum usable frequency and lowest usable frequency are in a range, the signal should go near straight up and then come back down within a 300 to 500 mile or maybe 300 to 500 kilometer radius of my station. So this is good for working the state of Iowa as well as surrounding states. This is a recent addition that I just set up, and I'm sort of working on tuning it now. It is tuned with that MFJ antenna tuner. However, the ground for it is actually the tower that the MFJ tuner is mounted on. And I think I could probably get a little bit better ground system in place for it, and it may perform a little bit better. For my APRS setup, you can see when I click near my location, there are a couple weather spots coming off there, my eye gate in the lower right hand corner, and my vehicle. So this is basically a cluster of APRS activity right around my home QTH. And here's a screen capture of the APRS coverage as drawn by APRSdirect.com. I've got pretty good coverage and even some stations outside of the purple circle that I'm able to pick up. So it looks like I've got 10 plus miles range using my setup, which I think is actually fairly good. In the back of my vehicle, I have a solar panel, and it basically charges a sealed lead acid battery that I have in the trunk, and this is connected to a Kenwood THD72, and that as my APRS tracker for my vehicle. So far it's been about 3 weeks, and I haven't had to charge the sealed lead acid battery manually. The solar panel has been able to keep it charged, and it does run 24/7. And finally, here's a picture of what's inside the trunk of the vehicle. I've got a bag that has the sealed lead acid battery in the upper right hand corner, and the larger alligator clips there are connected to the solar battery charger controller. That's the white box with the green header on the top and the black and red wires coming out the top and bottom. So that's what keeps the battery charged. I hope you enjoyed a brief tour of my amateur radio station, including both of my HF antennas, my VHF UHF antenna and APRS setup, my hotspot setup, and also my weather station setup. Thank you for watching. I hope to have more videos out soon, perhaps detailing some of my Mars radio setup, and perhaps some more amateur radio related videos on how to get licensed as a technician class. Thank you very much.